Hey there, this is Dr. Rishi from the Learners Academy, and today we are going to talk about the last topic in trigonometry. These are miscellaneous examples that have appeared in various boards, in various exercises. Now, I was not able to categorize these examples under one specific topic in all the 8 videos that we had done so far. So I have categorized them in a single video. I've clubbed them together in a single video and categorized them as miscellaneous examples. These would be using everything that we have studied so far in trigonometry. So let's go ahead with the first example. This example appears in 10th standard state board. It's a slightly different example because we don't have these kind of examples specifically for CBSE and state board. The example talks about eliminating theta, meaning we are replacing theta, that is the angle, and replacing it by numbers. So let us see how we can do these kind of examples. Eliminate theta from the given equations. X is equal to a cot theta minus b cosec theta, and y is equal to a cot theta plus b cosec theta. Now this is a kind of a special example. So let's see how we can solve it. Now, so we are going to replace the value of theta from here by x's and y's. This is called as elimination of theta. So let us see how we can do it. We can call this as first. Now these kind of equations are called as trigonometric equations. These would be introduced formally to you in 11th standard. However, 10th state board does have introduced them earlier itself. So this is one equation and this is the second equation. So I'll name them. This is the first equation. This is my second equation. Now I can say by adding equation 1 and 2, we get. Now since I add these two, on the left hand side I'd be adding x and y, so I'd have x plus y. On the right hand side, my second part is negative here and positive here, so effectively they'll get cancelled out and I'll end up with 2a cot theta. So therefore I can say cot theta is equal to x plus y upon 2a. The next thing I do is I subtract them and I have by subtracting equation 1 from equation 2, we get, so when I'm subtracting them, the first part would get cancelled out and I'll have on the left hand side I'll have y minus x, and it would be equal to, so the first part gets cancelled out and I have b, so this part minus this part, so it would effectively be 2b cosec theta. Since this is getting subtracted, it is itself a negative number, so it would get turned into positive and we'll end up with 2b cosec theta. Or I can say therefore cosec theta is equal to y minus x upon 2b. By my property, I know that cot theta is equal to 1 plus cosec theta, cot square theta is equal to 1 plus cosec square theta. So I can say that, so I can use this identity and use these two values of cot theta and cosec theta, and it would give me so from that identity I can say cot square theta minus cosec square theta is equal to 1. So I can get x plus y by 2a square minus y minus x by 2b square is equal to 1. Now I can further solve them out and I can take this 2 outside the brackets and it would give me x plus y upon a square, and here I'll get 1 by 4 minus y minus x upon b. Now this 2 can also be taken outside and I'll get a 1 by 4 here as well, and square it would be equal to 1, or I can say x plus y upon a square minus y minus x upon b square is equal to, now both these 4's can be taken common and taken to the other side, and I'll get a 4 here. So this would be my final answer. I can also further change it a bit and write it as x plus y upon a square minus x minus y upon b square is equal to 4. Now, though I have changed the sign here, I have not changed the sign outside because we are taking a square. Now, y minus x or x minus y square is always going to remain the same. So, this is how we have eliminated theta from the given two equations. So, if you see, these two equations have been mixed together and we have got this answer. However, there is no theta to be seen anywhere. This is one more example from 10th State Board, Maharashtra State Board. So it goes like this. It is from exercise number 6.1. This is sub question 9 of question number 6. That is, prove that. So the question is like this. Prove that if tan theta plus 1 upon tan theta is equal to 2, then show that tan square theta plus 1 upon tan square theta is equal to 2. Now this does look complicated. The sum says that tan theta plus 1 upon tan theta is equal to 2, and we have to prove that tan square theta plus 1 upon tan square theta is equal to 2. Now, the easiest way to do it is you take tan theta plus 1 upon tan theta and you square it. So if I square both the sides, I get tan theta plus 1 upon tan theta square is equal to 2 square. So this would be tan square theta plus 1 upon tan square theta plus 2 times tan theta times 1 upon tan theta is equal to 4. Now this gets cancelled and we are left with tan square theta plus 1 upon tan square theta is equal to 4. Now this is 2, so let's first write it as plus 2 is equal to 4, or I can say tan square theta plus 1 upon tan square theta is equal to 4 minus 2. So that is, the final answer would be tan square theta plus 1 upon tan square theta is equal to 2. And this is what we had to show. So it's a pretty straightforward yet complicated looking sum, and we cannot pretty much categorize it in any of the videos that we have done so far. Okay, so this is one of the toughest sums that majority of the students find it to be really tough. It actually it is not that tough. When we solve it, it is pretty simple and straightforward. However, most of my students who are studying in 10th State Board find it to be slightly difficult. This is from problem set 6, sub question 7 of question number 5. Let us prove the following. The question is like this: sec to the power of 6 x minus tan to the power of 6 x is equal to 1 plus 3 times sec square x plus multiplied by tan square x. So now the part of the problem majorly here is this sec to the power of 6 and tan to the power of 6. Most of the students panic because they see something to the power of 6 and they've never dealt with it. So now let us see what we are going to do here. First thing, we are going to use the tan sec property. What does the tan sec property say? The sec tan property says 1 plus tan square theta is equal to sec square theta. This is the property that we are going to use here. There is one more property that we are going to use. This property was taught to you in 10th standard. This property was taught to you in 8th and 9th standard under the topic factorization, where we studied factorizing cubes of numbers. The property was a cube minus b cube. The property was for a cube minus b cube. So we say using a cube minus b cube, before we go there, we will have to put this in this particular form. So I can say my left hand side is equal to sec to the power of 6x minus tan to the power of 6x. So that can be written as sec to the power of sec square x to the power of 3 minus tan square x to the power of 3. Now there is there is a property which deals with a cube minus b cube, which we studied in 8th standard and 9th standard. Many of you might have forgotten it, so it's a good idea to just make a note of it somewhere. So the property is like this: a cube minus b cube is equal to a minus b cube plus 3 times 3ab times a minus b. This property can be directly used here, and we can consider sec square x as my a and tan square x as my b. Now if I directly implement this property, my LHS becomes sec square x minus tan square x to the power of 3 plus 3 times sec square x multiplied by tan square x multiplied by sec square x minus tan square x. Now if we consider our identity here, we can say that sec square theta minus tan square theta is equal to 1. So obviously this would become 1 and this would also become 1. So it would be 1 plus 3 times sec square x multiplied by tan square x, which is equal to my RHS. So if you had seen it, the sum looked pretty complicated. However, if you knew this particular identity and you got an idea of converting this to the power of 6 into the power of 3, it becomes quite easy. So this again was a slightly complicated, a slightly different kind of a problem which we solve in 10th state board. Now let us go ahead with solving a problem from 10th standard CBSE. Now this sum is from 10th CBSE NCERT book. It's slightly different again. It says it's in exercise 8.4 in the old book, 8.3 in the new book. It is sub question 8 of question number 5, that is prove the following identities. The example is like this: sin a plus cosec a square plus cos a plus sec a square is equal to 7 plus tan square a plus cot square a. Now as we have discussed, the equation, the example was sin a plus cosec a square plus cot square a plus cos a plus sec a square is equal to 7 tan square a plus cot square a. Now here the problem is with this 7, as it's a larger number, most of the students do find it a little complicated. Now let us see how we can go ahead and get this 7 and a tan and a cot square from the sine and the coses that we have. From the sine, cosecs, coses and secs that we have. From the sine a, cosec a, cos a and sec a that we have. So we have the LHS is equal to sin A plus cosec A square plus cos A plus sec A square. Now this further we go ahead and expand both of these brackets, giving us sin square A plus cosec square A plus 2 sin A times cosec A plus cos square A plus sec square A plus 2 times cos A multiplied by sec A. Now we can certainly rearrange the terms. So I have a sin A here and a cos A here. I will separate them out. Sin A, sin square A plus cos square A. Then I will further separate these out. Now this is 2 times sin A and cosec A is 1 upon sin A. So I can replace this cosec A as 1 upon sin A plus, now since I've taken care of this, I've taken care of the first term, I've taken care of this term, and I will also take care of this term. So it would be 2 multiplied by cos A multiplied by 1 upon cos A plus I will write this cosec A plus this sec square A. Now since these are reciprocals, they'll get cancelled out, and the sin square A plus cos square A will be equal to 1. So I'd be left with 1 plus 2 plus 2 plus cosec square A plus sec square A. Now further I can just add these and get 5 plus cosec. Now since I have cosec and sec squares and I need tan and cot, I can replace the cosec A as 1 plus cot square A and the sec A as sec square A as 1 plus tan square A, giving me in totality 5 plus 1 plus 1, so that's 7 plus cot square A plus tan square A, or it would be a right hand side if I rearrange it, 7 plus tan square A plus cot square A, and that is equal to my RHS. So this is how I am going to solve a really complicated looking sum in a very easy and straightforward manner. Now let us go ahead and see some complicated sums given in 10th ICSE Selina book. Now let us take the sum. This is sum number 34 from exercise 21A from Selina Concise book. The example is as follows: sin A minus 2 sin cube A upon 2 cos cube A minus cos A is equal to tan. We have to prove this. So now let's see how we can prove it. So here on the numerator side I have sin A minus 2 sin cube A, and in the denominator side I have 2 cos cube A minus cos A, and we have to prove that it is equal to tan A. Since we have only sines and coses on my left hand side, it is evident that we have to reach to a conclusion which says sin A upon cos A. So here our agenda would be to get sin A upon cos A, that is to make the left hand side equal to sin A upon cos A. So let's see how we can do it. Here the LHS is equal to sin A minus 2 sin cube A upon 2 cos cube A minus cos A. Since we have a cube sign in both the cases, in the numerator and the denominator, majority of the students find it slightly difficult to grasp these kind of sums. So however, though they look difficult, they are pretty simple to solve. Now what is common between the numerators? So I can have sin a as common, and I'll get 1 minus 2 sin square a, and I'll divide it by cos a times, and in bracket I'll have cos square a minus 1. Now since I have a sin and a cos here, all I need to do is make sure that I equate these two in such a way that the final they can get cancelled out. So I can change the numerator to 1 minus 2. Now I know sin square a is equal to 1 minus cos square a. So I can replace it, this sin square a, by 1 minus cos square a, and I would get it equated to the denominator. So let's see how it works. So I have sin a times 1 minus 2 ones are 2 plus, now this, since there is a negative out here and there is a negative in here, it would become plus 2 cos square a divided by cos a times 2 cos square a minus 1. Now this, since it is 1 minus 2, it would become minus 1, and I'll get sin a times 2 cos square a minus 1 divided by cos a times 2 cos square a minus 1. Since these are same terms, I can cancel them out, and I would get it as tan a, which is equal to my RHS. So though the sum looked difficult at the starting, we can pretty much solve it in a very easy format. So let us take few more examples and conclude this series on trigonometric ratios. Now we come to an interesting sum. It is slightly different as compared to the sums that we have solved so far. So we'll see how to solve it. The sum is example number 7 from Selina Concise maths book for 10th standard from chapter 21, that is trigonometry. The sum is as follows. If tan a plus sin a is equal to m and tan a minus sin a is equal to n, then prove that m square minus n square is equal to 4 root mn. Now let's see how we can prove this. The sum says tan a plus sin a is equal to m and tan a minus sin a is equal to n. And we have to prove that m square minus n square is equal to 4 root mn. Now this is somewhat similar to the elimination of theta sum that we did in the first part of this video. However, it is different. It has its own it has its own way of solving it. So now, since I have m square minus n square, I can write it as m plus n multiplied by m minus n, and then I substitute the value of m and n. So I would get it as tan a plus sin a plus tan a minus sin a. This would be my m plus n, and I would multiply it out by tan a plus sin a minus tan a minus sin a. Now the reason I have used some extra brackets is because there is a minus sign here, and many students goof it up when it comes to putting minus signs like this. So here I can write tan a plus sin a. Now I open up the brackets, so I get plus tan a minus sin a, and it gets multiplied by tan a plus sin a minus tan a plus sin A. Giving me, now since there is a plus sin A here and a minus sin A here, they would get cancelled. Same way, plus tan A and minus tan A that are here would get cancelled, and I would end up with 2 tan A multiplied by 2 sin A, giving me 4 tan A sin A. I will consider this as my first statement. Now let's see the right hand side here. It is 4 times root of m by n. So that would be 4 multiplied by root of m. M is tan A plus sin A, and my n is tan A minus sin A, giving me 4 root tan square A minus sin square A. So this can further be written as 4 times root of, now since tan and sin are two different ratios, I will have to make sure that I convert them in such a way that I get my final answer in sines. So I'll get sin A upon cos square A. So I'll get sin square A upon cos square A minus sin square A. So this can be written as 4 multiplied by root of, now since the sin square A has no denominator, I'll have to make its denominator as cos square A. So I'll have to multiply this part by cos square A, and it would give me sin square A minus sin square A times cos square A divided by cos square A. Now, if you see, I have sin square A common in both of them, so I can take it out, and I can write 4 multiplied by sin square A times 1 minus cos square A divided by cos square A. Now this cos square A, this 1 minus cos square A can be replaced by sin square A, because according to the first identity, sin square A is equal to 1 minus cos square A. So I can have sin square A times sin square A upon cos square A, which would bring us to the end where we have sin square A times tan square A, because sin square upon cos square A is tan square A. Now since I am taking square roots, I can write it as 4 sin A times tan A. This would be my second statement. So as we can see, my first statement and my second statement are exactly equal. I can conclude that m square minus n square is equal to 4 times root of m multiplied by n. So friends, thus we conclude our series on trigonometry. In this series, we have made 9 videos dealing with basic trigonometric ratios, that is sine, cos, tan, cot, sec, cosec. Then the complementary angles of these ratios, then the values of these ratios at particular angles, that is 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. We also studied 3 identities that are associated with trigonometry and the reciprocal ratios. We also studied how we can use these ratios to find heights and distances. And today we had taken a special video on miscellaneous problems that occur across the boards in trigonometry. I have tried my best to cover as much as possible. However, trigonometry is a very large subject. So in case it has occurred to you that I have missed out on something, please go ahead and comment in the comment section. Also, don't forget to like our videos and share it with those who need them. Also subscribe to our channel and ask your friends who are studying in standard 9th and 10th to subscribe so that we can help them out with their maths. This was Dr. Rishi from the Learners Academy signing out. Thank you. This was Dr. Rishi from the Learners Academy signing out. Thank you.